Get them?
Good morning, all. Monday, January 24, 2022 is a white day today. Lunch, French toast, sticks and eggs, steak, fish and cheese, ham and cheese salad, crispy chicken salad. The main line, Spark and Grill, popcorn chicken bites, fish nuggets. Activities today, 5:30, girls JV and boys basketball, 6 times more here. All at 7 o'clock by girls JV and boys JV, 6 times more. Either varsity will be tomorrow night.
I see a
If you email, just do the one from Mr.
Jack
Knight last week.
Ava
And the rest of the make sure you contact Mr. Knight.
Maria.
Wall this week.
No, it was
You
Mariah.
have your student ID.
That's right.
Your current ID, you should take a picture of that. Make sure you get in the office to get that as quickly as possible. Snowball tickets are on sale this morning. So again, they're $7 here,
You
$10
sell
after all.
out.
We sold all week. The office is short staffed on Thursday and Friday, so no IDs will be paid after 3:15 on Wednesday. Also, if you're planning on bringing someone that is not a Spearfish High School student, the school guest sheets must be turned in prior to 12:15 Thursday. Items of note, invested in the health industry, Scrubs Camp will be at the Joy Center here at Spearfish on Black Hill State University campus in March. In the law enforcement youth trooper academy, both those items, information is available in the guidance office. All, please stand for the pledge. All have a great day. Great week.
Isaiah. Beta test, Callie. Carter. Remember, open notes, open book, open everything, close mouths. Show me you remember how to do a quadratic. Basically, you need to know how to do this forwards and backwards, 4 different ways, or else you're probably in the wrong room. Okay, I'll tell you that it is factorable. So you can solve this by factoring, calculation on graph, complete the square or quadratic formula. You just have to do it any 2 of those ways and have some work shown to back it up. Fins here. Matt is out. Remember to label them. 03B. Date doesn't matter. I can't remember what day of the week it is half the time anyway. Don't put like daily quiz number 4 or whatever. That I don't know what that means. Just throw 0B up there, or 03B. Remember, I want to know what you know, not what your neighbor knows. This is your gut check moment. Do I know how to do this? Not me and my friend know how to do this. Do you know how to do it? It's like a trial run before your the tests. Three, five, negative 5 halves, 3 halves, 3 halves, 5, 3/4 squared, 9/16, negative 40/16, negative 31/16, 5, I root of 31 over 4. Who's still going? Cool. So, if you had tried to go calculator route, come on, Frank, keep up. 2x squared plus 3x plus 5. I say graphify. Okay, what do you remember about quadratics? If I see that, what are the solutions? Ruh-roh. What are other words for solutions? I heard muttered intercepts, zeros, solutions, roots. Okay, they're roots because they are the binomial factors. They are zeros because when y equals 0, I will get these values. And when y equals 0, that is anything hitting the x-axis, so they're x-intercepts. If I see this graph and it has no x-intercepts, then it has no real solutions. So right out the gate, I know I need to run to, I know I just barely glanced over it in my algebra 2. Do you ever do factoring with imaginaries? Like, I barely glossed over it, and people kind of went cross-eyed, so I just kind of left it at that. And okay. It means I have to run to quadratic formula and complete the square. So, if I'm going to quadratic formula, x is negative b plus minus square root of b squared minus 4ac, womp, all over to a. In there goes a, b, and c. 3, 3, 2, 2, 5. Take care of the parts that you can all together. Order of operations. This thing. I got 9 minus 40 is negative 31. This thing is 4. So, 31 can't be simplified in all, but a negative 31 turns into a I. Okay, so there's round 1. Round 2, I have to complete the square on it. Step 1, eliminate the Canadians. Divide everything by 2. And I don't know about y'all, but I like kind of just one-shotting that and also doing step 2 at the same time. I mean, in fact, those two are interchangeable, so it doesn't matter. Variables on right, or variables on left, constants on right, divide by a. Complete the square, and completing the square is adding b over 2 squared. Currently, b is 3 halves. 3 halves, well, what's half of 3 halves? Okay, think about pizza. Cut it in half. If I cut that in half, it is now in quarters. Basically, you double the denominator, right? Dividing by 2 is multiplying by a half. Dividing by fractions, easy as pie, flip second multiply, all that kind of business. So half of 3 halves is 3 quarters. 3 quarters squared is 9 fourths. No, 9 3/4 squared 9 16ths. I'll give it to you because I thought it, but you said it as I thought it, so you got me. You were quicker on the draw. The alarm bell went off in the back. Wah, 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 and you already had said it, so bummer. Okay. Means I need to multiply by 8 to get common denominators. Negative 40 16ths and 9 16ths is again 31 16ths. My binomial is always x plus b over 2, in this case 3 quarters, the quantity squared. And the reason we want to stay in fractions and not go to decimal town, A, decimal town, unless you're writing the entire terminating decimal, then you lose part of your answer and this doesn't work at all. B, 9 times out of 10, when you write that denominator, it's going to be a perfect square. So square root both sides. Plus or minus I root of 31 over 4. And then do the thing. Subtract that over. X is. I suppose we should, like, there we go. So here's how we do it. 1, do you got the formula set up? Did you get to the right answer? 2, did you, I'm actually going to leave 2 in here for the work because that one may be a little more involved. Meaning, did you add it to both sides? Did you square both sides? Did you remember to cut it in half before squaring it? There was several steps right there. I'll leave a 1 as a floater for I did the dumb. I missed a negative, so I don't have my I. I moved 5 to the other side, but I didn't subtract 5 to the other side, so now it was a positive 5/2, and that ruined everything. Okay, however you're going to do it. But it's something out of 5. 1 point for the answer, 1 point as a floater, 1 point for quadratic formula, 2 for complete the square. Minus any just arithmetic errors that are going to happen when you do math. These are skills that you should have because it should have been beat to death in Algebra 2 because you learned it in Algebra 1. The only thing that was different in Algebra 2 is we taught you what an imaginary number is. And it was no different, just take that negative and throw an I out. Okay? Now, over the course of a weekend, I did not hear any questions regarding actual math. So, speak now or forever hold your pieces. What do we think? Hey. Come on, you. There you go. 34. Solve each by completing the square. I already got my constant on the other side. Yay. I just need to divide everything by 3. So I turn that into g squared minus 4g is a negative 4/3. b over 2 squared. Currently, b is negative 4. Half of that is negative 2. Negative 2 squared is 4. When you write your binomial, it's always variable plus half of b squared. Common denominators, 4 is really 12/3. So that becomes positive 8/3. Maybe the problem we ran into is when we square root, just simplifying radicals. Square root of 8 is square root of 4 by 2. Square root of 3 is just square root of 3. So square root of 8 is 2 root of 2. Have to rationalize. Getting plus or minus 2 root of everything inside radical land stays in radical land, 6, over square root of 3 and square root of 3 is square root of 9. Square root of 9 is 3. And then I'll have to add that 2 over to the other side. So maybe, is that where we got hung up, was the radical itself? Yeah. Yeah.
How do we do number 4?
Well, I don't know. What's we're doing? Okay. All right. 41. Y'all remember being back in Algebra 1, you'd get the word problem and no one in class did it? Like, just no one even attempted it. You saw words and quit. Okay, and then you got to Algebra 2 and we did the same thing and said, hey, you did this in Algebra 1? And everyone's like, no, I didn't. They said, well, you should have. And now we're doing it again. This is the classic example of quadratic application problems. Y'all, ACT, right here. You know how many 4.0 kids get a 22, 24 on their ACT? And wonder why they're not getting a billion scholarships because they got a C or a B level score on their ACT? It's because of stuff like this. Okay? Frame crop photograph, area of 20 square inches. The photo has an area of 20 square inches. Uniform matting around it. Read an equation to model the situation if the length and the width of the matting must be 8 by 10 respectively to fit in the frame. This is very, very common. This is like the showcase problem. If I was to ask everyone in here, I want you to think of an ugly dog. How many of you just thought of a pug? Okay. Oh yeah, pugs are awesome. It looks like a normal dog that ran face first into a wall, right? Well, that's an ugly dog. It's a cute ugly dog. We convince ourselves it's cute when it's ugly. It's like the common go-to example, right? If I were to ask in this room, who's a really tall kid? Like everyone's whipping their head back right now, right? Got Isaiah and not Carter, other one. The other Caden, that's right, Caden and beta test. Okay. So, like, y'all are both really tall, right? Those are the go-to examples. This is the go-to example for quadratics. If this whole thing is 10, and then I take framing and framing off, what's the width of the picture? Minus 2x. So this right here is 10 minus 2x. Can't even see that. Can't even see that. Okay, from here to here. So if the whole thing is a 8 by 10 frame, well then here to here is 8. What is here to here? 8 minus 2x. And it said photograph has an area of 20 square inches. Length by width. Binomial times binomial. 10 minus 2x times 8 minus 2x is 20. Distribute everyone to one side of the bus, solve quadratic. I know you know how to solve the quadratic. It's can we set it up? And this whole, there's a thing in the middle, and I either add x's on the sides or subtract x's from the sides. That's like dawn of time kind of quadratic problem. I know you've seen it dozens of times. You probably just saw words and didn't try. Okay? You can find out in here, I'm huge on honesty, like brutal honesty. Be honest. How many of you did this problem on your own? Like, I saw it, I reasoned it out, I did the thing. Okay? 2, 3. How many of you saw the problem, tried to think about it, got stuck, looked at the solutions, and then you were able to work your way through it? Okay? That's what they're there for. I want you to do that. How many of you saw the problem, saw words, and was like, nah, went straight to the solutions and just copied it down? I know someone did. Okay? I don't care. Like, be honest. It's about being honest with yourself. I have those resources there for a reason. When y'all go to college, when you take your dual credit math class, if it has a textbook, y'all go get the solution manual. Go on to Craigslist, go on to eBay, always meet at a public place with a friend. And like, legit, never ever at a person's house. Even if someone says come to my house to pick up thing, say like, I'm not really comfortable coming to your place. Is there somewhere can we go to Burger King's parking lot? Okay, something like that. Like just life tip. But this type of problem, no, it's been doing that for a while, or should have been doing it. This is one of the few instances where you should have been working with quadratics in geometry. Okay. Anything else? Cool. Then today should be 0405. Should. Asterisk. Okay. First, some basic vocabulary. What is this? Okay. It's a radical. Okay. This is a radical. Now, because there is no meh there, we would assume it to be a square root. If there is that thing, there is no number in that spot, I assume it to be square root because that's the lowest our roots naturally go. What is n? What's it called? Ooh! Nope, that's inside. But we remembered vocabulary, yay! Radicand is the thing inside the radical. Okay. This is called an index. The index of a radical determines the level of the guard in front of radical jail. Okay. If it's a square root, you need a square. You need 2 of a factor to get out of radical jail. If it's a cube root, I need 3 of a thing to get out of radical jail. And so on and so on. Okay. So just basic vocabulary there. Oh, just like when you do when I take a base to an exponent and get number, what is number called? Like 3 to the 4th is 81. What is 81? Specifically, it's the 4th meh of 3. It's the thing that I would sorely abuse if I was a supervillain. Power. Seriously, I should not be trusted with any superpowers. I'm far too petty and vindictive. If I have a index radical of a radicand, I get a root. Okay? So just making sure that we know basic vocabulary. I'm never going to put vocabulary on a math test. You're never going to have fill in the blank, define the term, matching, anything like that on a math test. But instead, it's just expected you know what the terms mean. You got to know what they mean, because otherwise, how many times have you gotten to a problem, you see the question, and you have no idea what they're even asking? Because I don't know what that word means. Okay? So we have to get that out of the way. Oh, the even and odd thing. We said before, and not Microsoft bought Blizzard, so now Call of Duty's dead. Okay, commandment number 2, thou shalt not take even root of negatives. So there's this little chart here where if I take the nth root of a number and get a to the, I'll say m. If we have n is odd. And I'm trying to go to variable land. We're not at variable land yet. We're not at variable land yet. Never mind. That's like 2 examples down the road. Basically, since we have the second commandment of domain that says you cannot take the even root of a negative, I'm perfectly allowed to take the odd root of a negative. What's a cube root of 64? 4, right? Cube root. 4 times 4 is 16. Times another 4 is 64. So what's the cube root of negative 64? It should be negative 4, right? Like, I'm allowed to do a cube root of negative 64 because that's the cube root of negative 1 times 4 cubed. Cube root of 4 cubed is 4. Cube root of negative 1 is always negative 1. Right? Negative times negative times negative. Negative. Versus the square root of negative 64, you write something squared times the negative 1. Well, that's 8. And that is a non-real answer. That's why we had to go to imaginaries. Okay? So just be careful as we're working with them. Odds are allowed, evens are not. Basic algebra 1 and 2. Simplify them, if you can. If you can. If it is a non-real answer, then you either say not possible, or if you are able to write it in terms of I, do so. And I'm pretty sure I said this last week. If I see just square root of 49, I should only be writing 7. When does the plus or minus show up? When we put the square root there as part of solving. If it's just radical and it's already there, then this is called the principal root of a thing. That's what allows me to say if this negative is out front, then my answer is a negative. Okay? We said before when we were doing our complete square and quadratic formula review, if I do a square root of a fraction, it's a fraction of separate square roots. Same thing goes for cube roots. This is the third root of 64 and the third root of 27. Getting 4/3. You should know perfect squares through 20, cubes through 10, fourths through 5, as many powers of 2 and 3 as you can get your hands on. What's 2 to the 6th? 64. Okay, you got to stop and think about it and actually do it in your head. What is 7 to the 3rd? Yeah. Okay. These are things you should just know. Again, I don't require you to memorize anything. But just like you are better at factoring a quadratic if you know your multiplication facts, you're going to be better at all of these different functions that have powers in them if you know your powers. Okay? And then this one, I'm just going to say non-real. Okay, we can't do that, not yet. I think Spear runs through the proof of 4th, 6th, 8th, all non-square roots of negatives in calc. I think he does. You can do it as far down as Algebra 2, but we didn't because there's no application for it yet. But there's thing, there's thing. Okay. Ah, there we go. Once variables are allowed, if I'm stuck, I can always write things out the long way. Ah, that's one too many. If I can count right. No. Who do what?
That's not 18. Do we get a brownie for it?
No, because I have to pee and I'm distracted. So, remember, it's a level 6 guard in front of the jail. Okay, Big Beefcake is standing there. He spends all of his time, spare time, like weightlifting and just, grunting. You need 6 factors. I need something to the 6th to get past that guard. I've got 1, 2, 3, 4, 5, 6 guys. Ah! They all rush him. 5 die in the process, but it was a valiant attempt. 1 gets out. 6 rush the guard. Wait, 1, 2, 3, yeah. 1 gets out. 6 rush the guard. Oh, cool, I did count right. 1 gets out. So I get n to the 3rd. On the outside, no one left in radical jail. Do you remember your Algebra 2 training?
Wouldn't it be 18 divided by 6?
A, you just divide, right? And we'll talk about that with our rational exponents, where it's just 18 over 6, literally, and then you reduce it. But this is not the final answer yet.
You have to add absolute.
Right? Thou shalt not take even root of negatives. It's not possible for me to take a 6th root of a number and it comes out negative. If the negative is already outside the radical, that's one thing. But I can't take the negative out because negative times negative did not make negative. That's not possible. And I don't know what n is. So to ensure that it's positive, I throw absolute value on there. What if that came out as n to the 4th? Now I don't have to because anything to an even power is going to be positive, right? Positive, 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 positive. Makes positive. Negative, negative, positive. Negative, negative, positive. Positive, positive. No matter what, something to an even number is going to be positive. So I get this little cheater chart that you may remember from Algebra 2. That's what I was thinking of earlier, is that if I ever have a even root of a number, apparently we're going triple hash, and get a to the n. Okay. Boy, I'm really distracted. We're going to have to bail here in a second. The nth root of b is a to the m. There we go. If n is even versus n is odd. If m is even or m is odd. So if I take a even root of a thing and comes out with a to the 6th, we're good. I don't need any absolute value. If I have an odd root of something, it doesn't matter. I'm always allowed to have positive or negative results coming out of an odd root. I'm always allowed to have positive or negative results coming out of an odd root. Where things get scary is if I have an even root and get an odd power outside of it, I need the absolute value. Okay. Even index, make odd power. Have to absolute value to make sure that it is actually positive. Okay, so that little cheater chart there. You were one of the Katies, right? There was a Kate and a Katie. That was second hour? Damn it. Having back-to-back pre-calcs and like 50 new kids sucks. Which one are you?
Maddie.
Maddie. There was two Maddies in here. Where's the other Maddie? Wasn't there?
There was 2 Jadens, 2 Cadens, 2 Cowards.
Child number 17. Okay. You had said before, yes, you just divide. So if I have a fourth root of something to the 12th, there's 3 coming out, right? And none left over. So I've got a plus 1 to the 3rd is coming out. Fourth root of 81 is 3. But then I got to think to myself, I see a variable. Variable plus 1 to an odd power came out of an even index. I need the absolute value. Also, I put the absolute value on that, not on the whole thing. Again, it's just like I don't put, if I just see x, technically there's a 1x to the first over 1 to the first to the 1 root of. But there's all this stuff. We don't write it because it's redundant. I don't absolute value the entire thing every time. I only put the absolute value on the thing that needs it when I need it. Okay? So, with that little cheater chart in mind, those two. Who comes out? Do you need absolute value? All right, I'm going to keep screwing up right and left. Did you know caffeine is a diuretic?
Yeah, because if it was a negative, no, it's not. Did you get 5 plus 28?
Go. Don't have to ask, just go. Okay. Remember, there's so many things that you need with an index to get outside of radical land. Just like I can break this into 9 by 7, so part of it comes out, I can break this into y squared and y. So a 3 and a y come out. A 7 and a y stay in. Absolute value or not, on only the y. Okay. Same thing goes here. When I see fifth root of a thing, I'm looking for powers that are multiples of 5. -1, p to the 10th, q to the 5th, and q squared. As opposed to writing them all out and circling groups of 5, I just look for powers that are multiples of 5 and say the fifth root of -1 is -1. The fifth root of p to the 10th is p squared. The fifth root of q to the 5th is just q. So I got a negative p squared q on the outside, and then a fifth root of, still have a q squared inside, absolute value or not. Odd root. Odd root means no, I never need absolute value. You're allowed to have negatives come out of a odd index radical. Okay, so it sounds like we're a little sketchy on the whole, just on the absolute value thing. 4, 5, 3, 5. All of them. And try it again, just to double check that we're getting the absolute value thing right. Even index make an odd power come out. That needs the absolute value. Nothing else does. So if you ever have an odd index, you never need it. Hi.
So if we pull a 5 from 13, would that have to have an absolute value?
No, that's your principal root and it's not a variable. 5 is just 5.
So, you only need...
On the variables, because I don't know what the variable is yet. 5 is just 5. X could be anything. It could even be a boat. Okay. Those are the elements that come out. Who needs absolute value? X cubed, because even index, odd power. Odd index, Don't need it. Even index, even power, perfectly fine, because no matter what x is, x to the fourth is going to be positive. But y, on the other hand, I need absolute value because it's to an odd power. How y'all doing over in this corner? This is like the worst place to sit. Okay?
When do you do the -1 times e to the 10th?
If there was a negative in there. Say, for example, this one.
Like when you use
When do I use?
I and when you
I is specifically, by definition, the square root of -1.
Okay.
So if I have a cube root with -1, well then just -1 comes out. If I have a fourth root of -1, I say, can't do that. See you in 2 semesters. Okay? Yeah, like this, then I turn that into -1 times 7 to the third, because cube root of -1, cube root of 7 to the third. Okay?
So any odd index.
Odds can play with negatives. Yep. Okay. Cool. Rational exponents. They got it written all right here, but I'll put it over here in color-coded glory if I ever have. Well, make sure I use their same terminology. B and M. Okay. If I have b to the nth power inside of a mth radical, then those are just my numerator and denominator in rational exponents. The first time you saw this was back in Algebra 1. Okay, we've been working with this one for a long time. What I would like you to also add in here, because this one sometimes trips kids up, is also true for this. That n exponent of b can be on b itself, the radicand itself, or it can be applied to the entire radical, and this will not change. It will not change at all. And the reason for that is, if I apply this definition, then this would be b to the 1 over m to the nth power. And whenever I have an exponent raised to an exponent, I multiply them, so it ends up there anyway. Okay? That's going to come in real handy when we're simplifying these things, because sometimes it's easier to find the mth root of a thing and then take it to a power, instead of taking it to a power and getting Gigantosaurus number and then trying to find the nth root of that. Okay? It's just, sometimes that trick comes in handy. And they don't always tell us this. I think our book does. But I hope you've seen that before. So back in the day, I would see pixelated 8-bit math problem here and say, well, it's a 10th root and a square root. I can't do that. They're not the same index. They're not the same radical jail, so they can't get together. What I can change that to is that's 32 is 2 to what power? Little invisible 1 right there. So this is 2 to the 5/10, and this is 2 to the 1/6. Which is 2 to the 1/2. And you got to remember your exponent rules from all the way back in Algebra 1. With an exponent divided by an exponent, what do I do with those exponents if they are of the same base? One person, muttered it. Okay, subtract them. 1/2 minus a 6th. Need common denominators. Call it 6/12. Oh, wait, no, I don't need to go that far. 3/6. Minus 1/6 is 2/6. Okay. Again, if you don't know how to work with fractions, 1, how'd you get here? 2, better have a calculator that you're good with. Let the calculator do the heavy lifting for you. My job is to teach you PreCalc, not to teach you 6th grade fractions. Okay? Yeah. And there's a lot of stuff to go through for PreCalc, too. We have the dubious honor of preparing you for the next 3 classes simultaneously. Because from here, you can go on to trig. You can go on to calc. Theoretically, trig is supposed to be part of this class, but we have it as a separate class entirely. Or you can go into stats. So we got a lot of stuff to cover, and yeah. Okay, this one, just more of the same. If I write that as x to the 21/4, like y'all know, that's just x to the 24th by x to the 1/4, right? Because when I multiply exponents of the same base, I add them, so I can also use that property to break them up. So I can say that's a x to the 5th on the outside, and then a 4th root of x inside. Here I'll have a y to the 15/4, which I can call y to the 12/4, y to the 3/4. This is y to the 3rd. Y to the 3rd comes out. They share the same denominator, so they can go in the same index radical. X to the 1st, y to the 3rd. It's a different way to do it. You don't have to do it that way. Personally, I would just, the way we were just doing it, right? But sometimes having the right tool for the job. Any of you ever needed the special screwdriver to crack open like a GameCube? Controllers were different. PlayStations, they had the 6-bit hex screws in them. Like, if you ever had to open a very particular device, A, you voided the warranty, good job. B, you also needed a special tool for it. Sometimes you need a special tool for it. Hi.
Do we need absolute volume on the exponent?
We do, and I got distracted. We weren't done. Yes, I need one on both because they're both odd. Sometimes you got to wait for the bouncing ball to stop bouncing around the room before you can pick it up. 3/4 minus 1/4 is 16 to the 2/4, which is 16 to the 1/2, which is the square root of 16, which is 4. Okay. Yeah. I do some, you do some. Can you simplify those? I'll tell you C, you need to break it up and simplify each part before you can go into rational exponent land. Mm.
Wait, Mr. Ford,
Yo.
if we're multiplying, we have to add these. So like if we're multiplying that, we add those.
Yes.
Okay.
I hope that we're also getting the math done in addition to the entertainment. I haven't had to do a seating chart in PreCalc in 3 years. And coincidentally, even then, it was, for some reason, a table of 4 boys, too.
That shifting root or just
Would it be 36 right there?
No, you never multiply the bases. They just maintain the base and then work with the exponents. Yes. No, it's only the exponents that change because we all about that base. So long as we're not completely off topic, remember, I want you talking to each other about the math. Okay, this isn't a solo adventure. You're all set up like Senate chamber for a reason. I want you discussing the problem. I want you working through it together. Checking with your neighbors, making sure you're getting the same thing. What if you got the same thing and you got there a different way? Was that coincidence and one of you screwed up, or was it a legal move? Fortune cookies are garbage, but I love that. Do we have to who what? No. Question about A, or 4. 6 to the 7/12. That's the 12th root of 6 to the 7th. Do you happen to know 6 to the 7th off the top of your head? I can get 4th power fairly easily, but past that I start to lose it. Okay, big number, right? So you got the option here. You can leave it like that, or actually write out big number. Either one of them they're both correct. And there is no real rule for when you switch between write the number out versus just leave it as an exponent. the way that I do it is basically if it's one of those, squares below 20, cubes below 10, fourths below 5, and so on, if I know the number, I'm going to write it. If this was instead the 12th root of 6 to the third, well, A, I'm going to reduce that and say it's a fourth root of 6, right? Because that's 6 to the 3/12, which can reduce. But B, I know what 6 to the third is. I would write 216. The correct way is to actually reduce it down to fourth root of 6. But just as an example, if I know that number, I'm going to write it. If I don't know the number, generally once you start getting up into the 10,000s place, it's too big, just leave it as an exponent. Or that's kind of my rule of thumb. Trying to remember where rule of thumb comes from as a phrase. Huh. X to the 2/5 and x to the 2/10. Well, 2/10 becomes 1/5. 2/5 minus 1/5 is x to the 1/5. Is fifth root of x. Does anyone remember if I can use that simplify rule, that I could also do it like this? And now because they're both inside the same radical, now it's not the fifth root of x squared over the fifth root of x, it's the fifth root of x squared over x, which also reduces. See, what happens with exponents and radicals is because they're built on repeated multiplication, and multiplication is commutative as an algebraic structure, that means you got a bunch of different ways to do the problem. Like, you could solve the problem, even a simple problem like this, probably 8 different ways. And that's perfectly legal, so long as you follow math law. The example I usually use in class is, as long as you're following the law, there's multiple ways to get to the end of the road. If I ask everyone in here, how do you get from student parking lot over to Walmart? Depends on the person, right? Someone is going to say, okay, A, if you've been here before, welcome to second semester with Sullivan, because I don't get new material, I just get a new audience. The idea is, one kid might say, okay, Emma's going to say, I'm going to go out the parking lot. What is that, Termis Avenue, I think? Right? The one that goes right by the mods and tennis court and all that? Yeah. Go on that, get on the main drag. Main drag is Colorado Boulevard until you hit Main Street, or Main Street until you hit Colorado Boulevard. One of those. Okay. Hit the intersection at Jackson, head east, get on interstate. Interstate until exit 14, question mark? 14, pretty sure it's 14. Okay. So Emma's going to say, main drag, Jackson, interstate, pop off at Walmart. Okay. Kaya, on the other hand, is going to say, I'm going to take the main drag all the way through town instead of the interstate, because I want to go by Dairy Queen to see if that one girl's working over there, and I'm going to stalk her. I mean, hey, if she's there, then I'm going to stop and get myself a sundae, right? Okay. And then you got Finn over here who's like, no, I'm going to get on the main drag. I'm going to go north. And I'm going to get on the interstate at the north end of town and then get off over at Walmart, because I don't want to go through town. The cops know my car and they're going to pull me over if they see me because they hate me. Finn's had some issues. Okay. Finn's kind of shady.
The IRS is after me.
that one job where you hack them. No. How many of you have ever, when you first get your license, your parents tell you go pick up a gallon of milk, and you decide to take the roundabout way there because they didn't specify anything, right? Okay. Can you get to Walmart by route of Deadwood? Main drag all the way through, go hit the canyon, down to Deadwood, take 84, is that 84? 84A? 81A? All over to Sturgis, and then back on the interstate over. Could you do it? Yeah. You're going to see that with these problems. The more complex it is, the more multiplication that's commutative is involved, the more you're going to have 9 different ways to do the problem. As long as you followed math law, you got there. As long as you didn't decide you were going to off-road and try to climb over the butte here. You know, I got big tires. It's South Dakota. Yeehaw! And like, well, then you're just going to roll your truck when it flips over. Okay. 16, did we figure it out? They can both be simplified. This is 4 by 5, 27 by 5. See, when I can simplify these, that turns into 2, 5 to the 1/2, 3, 5 to the 1/3. Okay, if I can simplify them, it turns out that outside of radical jail gets to party, inside of radical jail has the same base now, the same radicand. So 1/2 plus 1/3 is 5/6. And again, because I know what 5 to the 5th is off the top of my head, then we're going to do the 31/25 6th root. Okay. But sometimes you got to break it apart to see its parts before you're able to work with it. You know, is it easier to take your shoe off and just scratch that part of the bottom of your foot, or are you just going to do this for half of class? And then you have to do that eventually anyway, right? So, review of radicals. Review of systems. On turbo through them because this is algebra half. Most of it. Okay, solve a system by graphing. The idea is line number 1. Y'all remember graphing by intercepts? Stick a 0 in for y, 3x equals -6, x-intercept is -2. Stick a 0 in for x, -2y equals -6, y-intercept of 3. Connect the dots. It also gives me a ratio of up 3/2. Versus the other one, xy intercepts of -2, -2. Gives me a slope of -1. I can use it to make some more points so I have a more accurate line. Okay. I do not get new material, I just get new audience. Blue line. My wife loves Mexican food. Real Mexican food. Not South Dakota Mexican food. If you have ever lived in the Southwest, you know what I'm talking about. Okay, we lived in Arizona, and she used to go get lunch at a little shack down the road where one person spoke kinda English. You'd point at the menu, say, I want that. It would only cost you $4. You'd come out with a styrofoam tray full of like a grocery store, and it tasted amazing. Okay. Blue line, my wife loves Mexican food. Red line, I hate Mexican food. I'm a texture eater. Part of being autistic means I've got a lot of sensory issues. Refried beans, might as well puke in my mouth. It's just mush. Most vegetables, ugh. Spices, I'm Irish and Norwegian. Salt, pepper, butter, ketchup. Done. Okay? We like it bland in North Dakota, which is actually why Dakota Mexican food is such trash. But what is yellow dot? No, sir. Yellow dot, Guadalajara's, because it's close enough that she'll put up with it. And they got the gringo menu on the back. I can get a chicken sandwich and fries. Okay? It's the place that both conditions are satisfied. The blue line is the set of all solutions that will make this equation true. The red line is the set of all solutions that will make the red equation true. The point of intersection, make sure you actually say what it is the one magical location where they are both true, where they're both happy. Now, you can't always solve them by graphing, because what happens when they land at a nasty point? Then we started getting into substitution and elimination. Do you remember the process of substitution? Like, everyone's got their own jam. Some kids, like me, I'm an elimination guy. I went to elimination, never went back. To me, I would much rather multiply that bottom row by 3 and get rid of y. But do you remember substitution? Okay, the idea is, if I can isolate one of the variables, and you're like a lion stock in the herd. You want the weak and the sick. Okay, who up here is the easiest to get by themselves? Bottom y. So I'm going to subtract 5x, multiply by -1. Y is a 5x minus 14. Well, if I just said y is this junk, then replace y with that junk. That turns into 2x plus 3 by stuff is 9. And then it's like you're back in, pre-algebra or whatever. You disturb it, combine like terms, add 42 over, divide, yay. And how many times did you get that wrong? Because you got x equals 3, mic drop, move on with my life. Okay. This goes for math and life. If you have an x, you better find out why. Thank you for pity laughing at that dad joke. And then make sure you write it as a coordinate. Okay? So substitution, elimination. Elimination to solve, well, remember the whole idea behind this is that things are balanced. That's what an equation is. It's the fulcrum on a teeter-totter. If I were to take the middle row here and say you two are balanced with you two, I put you on a teeter-totter and it's perfectly balanced. You just sit there and stare at each other. Third row, same thing, perfectly balanced. You just sit there and stare at each other. I should now be able to take all 4 of you and put you on one side, all 4 of you and put you on one side, and it's still balanced, right? 3 equals 3, 5 equals 5, 8 equals 8. They should still balance. So that means I can take any multiple of them and I can add them together. Would you rather eliminate x's or y's? Okay. Most kids are going to go with y's because 2 things. A, they're integers right now, so it's easier to do the mental math. B, one's already positive and one's negative. If I don't have to multiply by a negative, that's one more thing I don't screw up. So I'm going to take this row times a 5, and get 7.5x plus 10y is a Hondo. Now I'll take this row times 2, getting 5x minus 10y is negative 50. Get 12.5x. Zeros out is 50. Divide x is 4. Okay. Old school elimination. Chapter 6, Algebra Half. Now, yet again, I found out x. I need to find out y. Which one do I put it in? It does not matter. Remember, this is the solution that makes both equations true. So it should work in either one of them to find out the other part of the coordinate. I'll just use this one because it's handy. We'll say 2.5 times 4 minus 5y is negative 25. So that's 10 subtracted over, divide. And then write your coordinate 4, 7. Okay. We're going to come back to example 4 because that's the actual meat and potatoes of section 05. Instead, we're going to talk about the graphs. Y'all remember a solution to a system is where they cross. So what happens when they never cross because they're parallel? No solution. Okay? My wife wants Mexican food. I want a peanut butter and jelly sandwich. There are no restaurants within driving distance that are going to offer both. Gourmet peanut butter jelly sandwich. Okay? I don't even know if that's probably a thing. Someone makes that a living. Consistent and dependent, sometimes the equations simplify down to being the same line or the same quadratic or the same whatever. When that happens, then you want to be careful. You notice that they say infinitely many. Why don't they say all real numbers? Is that a solution? Aren't those real numbers? So there's an infinite number of solutions because the graph goes forever. Then you start talking about infinite numbers within finite spaces, and it makes your mind like hurt. Pick a number between 0 and 1. A half. Okay. Pick a number between 0 and a half. Pick a number between 0 and that. Between 0 and that. 0 and that. 0 and that. 0 and that. Isn't there an infinite number of numbers in between any two numbers? It's a finite space, but there's an infinite number of possibilities within it. Right? If that idea, instead of making you go, makes you like, huh, go to Math Circle. Seriously. Like, do it. So that's why we call it infinitely many instead of just all real numbers. What you may not know is these. Some textbooks use that terminology, some don't. If something has a solution, it's called consistent. If it has one solution, it's consistent and independent. If it's infinitely many real solutions, then it's consistent and dependent. Depends on what the other is. Versus no solution is inconsistent. Okay. The way that they look when I try to solve them is, nope, not you. The way they look is when I solve here, if I go good old elimination, atom, atom, gone, gone, I get 0 equals 38. It's not a true statement. So that'd be no solution. We use the empty set for it. If I take this row times a -4, I get negative 20x minus 8y is negative 48. 0 equals 0. And I will see kids year after year in every level of math from algebra half up through pre-calc try to call that no solution. Does 0 equal 0? Okay, so anytime you get a number equals itself, the identity, it's all real numbers. You can write out all reals. No, it's not all real numbers. I just got done saying that. It's infinitely many solutions. If I was just solving an equation, basic equation, and got 0 equals 0, then I'd say all real numbers. Since this is a solution, it'll be infinitely many. Okay, so that's all the old stuff. In Algebra 2, we introduced 3 variable. 3 variable are not difficult. It's a step before and after a 2 variable system. Step 1 is to eliminate a variable 2 ways. Then you solve a 2 variable system. Then you go back and solve for whatever variable you eliminated. Okay? So step 1 says, I don't want 3 variables, I want 2 variables. So you look at x, y, and z and say which up there is the easiest to eliminate multiple ways. I can take top row times -2 to knock out 2x. Top row times -4 to knock out 4x. Middle row times -2 to knock out 4x. I also have 1s and -1s as coefficients on my z's. There's not a right answer. There's multiple correct answers. In fact, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I got 16 ways to start the problem. Just off the top of my head. Any of them are correct. The issue is one of organization. How many times have you done the problem, you get all the way to the end, and it turns out, oh, wait, I screwed up. You go back to look at your work, and it just looks like a pencil vomited on your paper. You have no idea what's what. Start over, right? Have a method of organization to this. I'm going to label my equations 1, 2, and 3. And I'm going to say, I'm going to use get rid of z's. It's just, to me, that looks easier. I'm going to say equation 1 and equation 2. Rewrite them. X minus 2y plus z is 15. 2x, 3y minus z is 7. When I add those two together, I get 3x plus y is 22. If I take 5 times equation 1, I get 5x minus 10y plus 5z is 75. With equation 3, 4x, 10y minus 5z is -3. This here is magical Christmas land, meaning it's something that only happens in movies. This doesn't always happen, but we managed to eliminate 2 things. Most of the time, you're going to end up with another equation there that has x and y. Step 1, eliminate a variable 2 different ways. Step 2, solve your 2-variable system. In this case, solving my 2-variable system is very easy because I just got 9x is 72. So I'd say x is 8, plug it in, 24, subtract it, y is negative 2. I have now solved my 2-variable system. Go back and solve for the variable you eliminated. I'm going to use equation 1. Say x minus 2y's plus z is 15. I know that x is 8 and y is negative 2. 8 plus 4 is 12. Subtract it over. Z is 3. Very end of the rainbow. I got 3 variables, so writing as a 3D coordinate. 8, negative 2, 3. Okay. Again, all of this is review of Algebra 2, or 1. In fact, this year, this is the first year we have moved 3-variable systems down to Algebra 1. Okay? Like, it's eliminate a variable 2 ways. Okay, solve a 2-variable system. Now go back and find out what the thing was you got rid of. Okay, 3 steps. But I want you to show me thumbs before the bell goes ding, though. I can do that. I remember it. I'm golden. I'm a little hesitant about it, but I can try it versus yo dog. This is going to be bad. Okay, so collectively we say all right. The assignment should be up and ready to roll. I think. Let me check.